This is an interesting paper. It's kind of long, so I'm going to skip the parts about geoengineering, which I have covered extensively in a couple of other places. But the argument here is that geoengineering is basically going to be a part of the solutions portfolio. Carbon capture you can think of as geoengineering as well, but there are more scary ones like going and spraying things into the atmosphere, stratosphere to reduce sunlight or use mirrors and deflect sunlight and so on and so forth, which can have unintended consequences. Even carbon capture theoretically can be unpredictable in terms of we are increasing greenhouse gases and then we are going to draw them down. Will it be that the things will be linear, that you are increasing extreme events now, let's say, and you will just start to reduce extreme events, or will there be redistributions of rainfall and heat waves and extremes and so on as we draw down greenhouse gases? So we are basically fumbling along on this, and geoengineering is going to add a bit more to the Frankenstein aspects of it. So this is a feature article appeared in Science recently in April 2025. I'm recording this in June 2025. Failure to communicate. Geoengineering could be crucial in the fight against climate change, but first scientists need to learn how to talk to the public about it. So you understand the focus here is that geoengineering is pretty much needed, will be needed, and we have to learn to communicate about it before we start spraying things. And this is an example here. Actually, scientists spray salt particles into the air above the deck of the USS Hornet docked in Alameda, California. They are spraying this at lower levels, and this is likely to produce cloud condensation nuclei, and it's a salt particle, so it's not very dangerous. And if clouds form, rain, whatever, it's not expected to cascade into some dangerous thing. But there are many other exciting things being tried. So it's a lot of text, so I'm going to skip many parts. As I said, I've copied the whole paper here, but I will try to keep it brief. When Marilyn Etsy Ashcraft, mayor of Alameda, California, scrolled through the New York Times on a Saturday morning in April 2024, a story about a controversial experiment caught her eye. Researchers from Washington State were trialing a machine that looked like a big snow cannon, which they hoped would one day be used to brighten clouds to reflect more of the sun's rays. They had been spraying tiny salt particles into the air over the San Francisco Bay. So brightening clouds increase albedo and reflect sunlight has been proposed, and as you see, this has been tried at some scale. It's been argued to be also a technique to save the Great Barrier Reef from heating, overheating, bleaching, etc. At first, Ashcraft wondered which neighboring town was hosting the test, but as she read, she was shocked to learn that the researchers were conducting their experiment right there in Alameda in her backyard, and she's the mayor. Ashcraft texted her acting city manager, who was equally surprised. The story revealed that the researchers had kept the test a secret to limit protests. It wasn't just an oversight that they forgot to tell the city, Ashcraft says. They chose not to. Concerned about the safety of the test, city staff investigated. Though a report concluded it was harmless, the council eventually voted to ban it, discomfited by the researchers' lack of transparency. I support this move because researchers cannot go and start doing things in somebody's neighborhood without engaging the stakeholders or people who will be affected. Ashcroft hoped this would be a teachable moment for the research team. Maybe they were just in such a hurry, or maybe they thought they could get by without being noticed, she says. Whatever it was, it didn't work well for them. It really backfired. The technology being trialed in Alameda was one of a suite of new geoengineering tools, many still in the earliest stages of development, that aim to modify the atmosphere or the ocean in order to fight climate change. Some of these tools are designed to remove carbon dioxide from the atmosphere, a step that, along with drastic emissions cuts, scientists agree, will be essential for limiting global warming to 1.5 degrees C. Others such as cloud brightening, don't counter the drivers of climate change but aim to limit warming, protecting vulnerable ecosystems such as coral reefs. But of course, the detail is that if you don't reduce emissions, you will have acidification in the ocean, and many other things will continue to happen because you are still trapping CO2 and greenhouse gases in the, putting more of them into the atmosphere. One thing these technologies have in common, however, is that they are at risk of being stopped before they can even be tested in the field. Researchers' ability to conduct even the most basic field tests depends on the goodwill of nearby communities, but critics charge that many project leaders that treat public engagement as a checkbox exercise or forego it entirely, as they did in Alameda. In the past 3 years, public outcry has thwarted several climate engineering projects. Others, however, have built enough trust to proceed. Their success has taught some key lessons, as has a flurry of studies by social scientists who are always needed to see the last mile socio-technological acceptance, transitions, and so on. These researchers have explored the kinds of concerns people hold about climate engineering, how to have productive public discussions about it, and even where to run the experiments themselves, yet their findings are rarely incorporated into the groundwork for field tests, because field tests are run by typically engineers, climate scientists, climate engineers, private entities. Bill Gates funds some of them, Jeff Bezos may be doing so as well, and so on. It's really, really hard to take them to be taken seriously, says social scientist Sikina Jinnah at the University of California, Santa Cruz. There's a handful of scientists who I think bend over backwards to support social science and to advocate for the inclusion of social scientists and their perspectives, but they are few and far between. So geoengineering, I'll skip. Basically, it's about deliberately altering the workings of the planet. Sounds ambitious, even arrogant. I have a section on hubris, human hubris of trying to do geoengineering without knowing all the unintended consequences and scope for Frankenstein experiments. So it's deliberately altering the working. So I don't know why I put it back in. So this comes in two main flavors. I won't go into the details because they have covered it extensively. Solar radiation modification, and where you are reducing the energy coming in with various approaches. And the second one is to do carbon removal, where you are not changing the energy coming in. Indirectly, you may be by removing greenhouse gases and carbon, but you're basically trying to remove the fossil fuel emissions and other emissions we are putting into the atmosphere, which is what is trapping the energy. Okay, so those are the two approaches, and obviously we have already argued that these are going to be carbon capture, at least, is going to be part of the solutions portfolio going forward if we want to restrict warming. 1.5 degrees C, 2 degrees C, made up targets, but still very useful to drive action. But we will probably go past both of them, so there are other details on what we really need to worry about. And here, David Ho, who I know, professor at University of Hawaii at Manoa, I don't know it's how it's pronounced. He says it's got to go from something that most people have never heard of to the biggest industry in the world has ever seen in a really short time in terms of carbon capture. And this is happening. Climeworks and various other companies are selling large-scale carbon capture technologies where air flowing through is precipitating out or scrubbing CO2 from the atmosphere. A lot of technical problems there we have discussed elsewhere, and they are expected to, or they are needed to be scaled up to gigaton levels if we want to seriously make a difference in drawing down carbon and sequestering it somewhere. So they are new and so on. So Sarah Nawaz comes back here to say she directs the research at American University's Institute for Responsible Carbon Removal Law and Policy. I think that there is totally the risk that one or several projects that get really stigmatized can just delay things or even just totally kind of take it off the table. So people are, really feeling unsure, and the whole industry is really at a vulnerable stage from a public perception standpoint, which makes sense. Can you really forego public? Foregoing public engagement has already had fatal consequences for solar geoengineering projects with ramifications for the entire field. There are some fairly aggressive people like the guy being mentioned here. So Harvard University backed stratospheric controlled perturbation experiment SCOPEX project was planning to launch a balloon in Sweden to study stratospheric aerosol injection, the theory that in releasing tiny particles of calcium carbonate or sulfur dioxide into the atmosphere will reflect enough sunlight to temporarily cool the planet. I won't go into the details, but basically the idea comes from volcanoes, because when volcanoes go off, this is what they do. They inject stuff into the stratosphere which doesn't precipitate out quickly and gets mixed around, and it reduces sunlight and cools the planet. But there are other consequences like droughts, reduced rainfall, and summer with year without summer kind of examples from the past volcanic eruptions which cause severe crop losses and so on and so forth. Okay, so in the lead up to the test flight, SCOPEX advisory committee debated the need for public engagement. Some members argued that the test flight bore little difference to atmospheric research routinely carried out without public consultation, whereas others advocated for transparency and dialogue. In the end, the committee ruled out that public outreach wasn't necessary. So just as with Alameda project, there were issues, experiments, and the technologies have much deeper meaning than just whether or not there is particles in the air, says Sarah Gina again. So, social scientists actually, and legal and ethical anthropologists, whoever, have to kind of track these things. The debate has continued, and there are, always efforts to do these experiments. Should engagement simply involve informing people, or should it be a process of building relationships with the communities and incorporating their concerns into research? So spraying sea salt in Alameda is one thing. It can be very local, especially at lower levels, but spraying particles into the stratosphere is not going to be very local. It can spread very quickly and have regional or even global consequences depending on how much they spray. So advisory committee could not agree on a plan, and the project leaders ultimately decided to pull the plug in 2024. And in an interview with MIT Technology Review, SCOPEX co-leader David Keith, who's going around the world, in fact, giving talks saying that this is actually beneficial for countries like India because it may increase rainfall. And he said that prominent failure could make this branch of research more difficult. I disagree with his model experiments and his claims that spraying stratospheric aerosols, actually, the experiments are kind of not very rigorous, or at least he couldn't explain them properly, and I'm openly opposed to trying this in the aggressive way that's being tried. There needs to be a committee set up to monitor this, evaluate it, and report progress, and have steps in place to deal with unintended consequences. If India suffers from this experiment, then who will pay for it? So these are not trivial issues. Climate engineering can be even more unsettling to the public than other controversial technologies such as genetic engineering, GMOs, protests, opposition, everything has happened. There are many socio-economic issues there in terms of farmers, whether they own the seeds and so on and so forth. But you're not just asking people what do they think of this technology or this field trial or this sort of machinery or activity, says Nawaz again. You're asking people to contemplate different potential futures that could arise. So you're asking them to think through, what do you want the world to look like in the future, with geoengineering maybe becoming routine? Because once you start spraying something into the stratosphere, what happens when you stop? And how long will you keep doing it? What are the consequences? Such outreach often meets with skepticism. In a study led by Livia Fritz, a social scientist at Aarhus University, hundreds of people across 22 countries in the global north and global south spoke in focus groups about how they believed geoengineering projects should be discussed. Most expressed disillusionment with engagement, not because they didn't want to be consulted, but because they had experienced bad faith consultations in the past that sought to convince rather than to listen. And that is the case with David Keith, I would say. Some participants didn't believe that public should be involved in decision making, citing concerns about people being manipulated by misinformation, then making consequential decisions. Fritz says Brexit, for example, was mentioned a lot here. She says she says the results point to the need for open consultation decisions. Fritz says Brexit, for example, was mentioned a lot here. She says the results point to the need for open consultation on climate engineering that isn't limited to issuing or denying permission for particular projects, but that allows people to consider and debate the technologies more broadly. Solar radiation modification research rouses other suspicions. Studies have found a strong overlap between online discussion of the technology and long-standing conspiracy theories, such as the idea that condensation trails from airplanes are in fact chemicals released for an unknown but nefarious purpose. Conspiracy theories, and they have been studied and published. Data-based diagnostics have published that there is no such thing going on. But there are countries. I have gotten a call from a country in the Middle East asking if U.S. is manipulating their climate to have them warm rapidly. Middle East is warming rapidly, so is the Mediterranean region, and there are energy balance. Calculations that show why drier places warm more during global warming. So the conspiracy theories and other misunderstandings are partly behind moves to ban or restrict solar engineering. There are bills passing through the legislature in 28 U.S. states to limit research or deployment of the technology, most of which were introduced in this year. Yet, engagement offers one form of inoculation against the spread of misinformation, according to a National Academies of Sciences, Engineering and Medicine report from 2017. Transparent communication builds trust. The report concludes, such as when scientists disclose funding sources or potential conflicts of interest or demonstrate a willingness to listen to public concerns. If David Keith runs a company, makes a lot of money, and is funded by oil companies or Bill Gates or whoever, then will public trust his assurances that nothing will go wrong, especially when he is not so much into listening but telling you why that could be a good thing, that spraying aerosols into the stratosphere will give you more rain. Gina says some scientists believe engagement isn't necessary because they feel the importance of the research should override public concerns, and because some people will be opposed to it no matter what outreach takes place. But engagement can lead to greater flexibility in people's viewpoints by diffusing tensions and resolving objections, says Rob Bellamy, a social scientist at the University of Manchester. People often display something that's called reluctant acceptance, he says. They're actually quite happy for you to go ahead and do your experiment because they recognize through the deliberative process that we are at a point now where we need to start considering these more controversial ideas. So people are not very comfortable, not totally happy, but they say, what the hell, we need it, so try it, but be careful, please, right? So researchers too may learn something by listening. Local people know their area better than anyone and might raise potential complications that aren't even on scientists' radars. Indigenous knowledge, local knowledge always adds value to global scale scientists who don't know as much. Cardiff University social scientist Emily Cox says research on carbon removal in the UK consistently finds that no one is entirely opposed to it. Rather, people want to know whether the large arrays of energy-hungry machines might create competition for electric power or increase housing pressures by occupying much-needed land. Not all technologies that are divided should go on to be deployed, Bellamy says. I'm certain there will be some technologies that won't go on to be deployed for very good reasons, scientific, not just social or public concerns, and public participation helps us feed into those decisions. Okay, so let's look quickly at the turbulent history. Scientists have suggested using geoengineering to combat climate change since the late 20th century. Solar radiation modification includes proposals to reflect sunlight away from Earth, whereas marine carbon dioxide removal includes technologies for changing the chemistry of the ocean to speed up its absorption of the carbon. I've discussed them elsewhere. Field trials of the technologies have accelerated in the past 5 years, but public perception remains fraught and many projects have foundered. Okay, so 1974, Soviet climatologists proposed releasing sulfur. 1980, July 1988, oceanographer John Martin sparks, iron fertilization ideas and creates excitement. Many experiments happen, and then there was a conclusion that they don't work and they should be banned, and now they are back in vogue in terms of scientific trials. September 90, British cloud physicists say spraying salt water to make clouds brighter could work. April 95, paper proposes sequestering carbon dioxide by increasing ocean alkalinity. Iron fertilization again comes up in 24. In 2008, UN puts a moratorium on ocean iron fertilization, as I mentioned, based on scientific inputs and data from the other experiments that were already carried out. September 2009, a Royal Society report spurs interest in carbon removal and solar engineering. There are some in the UK who strongly argue that carbon capture is a no-brainer. We must go ahead with it. I agree, because it's pretty much necessary now, but we need also studies to say how things will change as we draw down CO2, which is not about to happen because scalability is still an issue. So similarly, aerosol injection test is cancelled in May 2012 by the UK. US entrepreneur Russ George slammed for dumping iron into the ocean to revive fisheries with this idea of iron fertilization, but was done again without engagement and without any scientific backing. Canadian non-profit sparks protests after applying for permits to dump iron near Chile. So we then move to more recent times. I won't read all of them, but there is inadvertent brightening of clouds by the contrails of ships, which are now considered a bad thing because they allow sunlight to come in and can trap outgoing long-wave radiation, so act as greenhouse agents. 2020 again in March, this was in January, March, Australian scientists begin testing cloud brightening, as I mentioned, for Great Barrier Reef protection. Scopex cloud brightening that we mentioned, Harvard group protest is held over planetary technologies, ocean alkalinity enhancement in Cornwall, England, and the project is put on hold. Vesta conducts ocean alkalinity enhancement with public support, with at Little Peconic Bay on Long Island with public support. May 2023, NOAA special report suggests there is still potential in iron fertilization, as I mentioned. 2023 planetary technologies field tests take place in Halifax. So when you have a lot of commercial entities involved in these, they are looking for another thing that could be offsetting carbon. So somebody is emitting carbon and they say, I'll fund this geoengineering to offset my emissions. So emissions may keep increasing, so reducing solar radiation may not at all remove many of the impacts of increasing greenhouse gases and pollutions like ocean acidification and other impacts on crops and vegetation and human health and so on. March 2024, Scopex project is cancelled. Alameda, California, we read already. Vesta conducts a field test in Duck, North Carolina. Spring 2025, just as I'm recording this a couple of months ago, Planetary Technologies is conducting public engagement ahead of field trials in Vancouver, Canada. So there is aggressive attempts to try this. I won't go into this because we have looked at it, but stratospheric injection, marine cloud brightening, ocean iron fertilization, artificial upwelling, ocean alkalinity, enhancement. Each one of these is discussed in podcasts in detail. Okay, so jumping ahead, I might have lost some text there, which I think I did, but doesn't matter. Let's just jump ahead. And Cornwall is known for its environmentalism, the experiment we mentioned. And a member of the public asked what would happen if something went wrong. Kelland said Planetary would go out of business. It seemed to more than one attendee that he hadn't considered what might happen to the bay itself. He was just worried about himself and his company. They were concerned by what they saw as attempts to downplay the chemical the company was using by describing it as an antacid for the sea. The meeting was dreadful, says Sue Say, a researcher who studies the seal colony in the bay and directs the non-profit Cornwall Seal Group Research Trust. They did 20 minutes for discussion, and then it was pastries and wine, and everyone refused to leave for the pastries and wine and said, "We are not leaving until you answer all our questions." So you get the idea that there are more and more examples of how people are trying to engage and feeling disappointed, or trying to hide their experiments and then getting caught and paying a price and just facing opposition. And Kelland had obtained environmental safety review. He had been meeting stakeholders all over the region. Even the mayor of Hale was in support. What was missing was an understanding of the region's history and identity. In Cornwall, people have a reason to be skeptical of the use of chemicals in the sea, because in 1967 a tanker foundering on the coast caused one of the world's largest oil spills at the time, and in recent years beaches have been polluted by sewage discharged by the same utility company that was to be Planetary's partner. I think a lot of it is doing your homework in advance and understanding what you are getting yourself into, which I don't think we did very well in that location, Kelland, so they learned their lessons. So Planetary's work in Cornwall never resumed. The trial planned in 2023 remains on hold. So that's more on the Cornwall project, which obviously I reversed in the arrangement. But in the US, people in more deprived areas may be more skeptical of untested technologies, as they are often still facing the consequences of prior industrial pollution. These regions, which often have existing infrastructure and an underemployed workforce, are good candidates for running operations once the technology has become more established. A 2023 document from Lawrence Livermore National Laboratory concludes, whereas areas with higher socioeconomic status may be better suited for collaborating on early trials. Okay, so these are the protesters here, a campaign against the planned trial by Planetary Technologies that we discussed. Keep our seas chemical free. Who is in charge can also make a big difference. Always credibility, legitimacy, and salience matter. In a collaboration with Cox, Bellamy has found that people were more likely to say they would oppose a hypothetical ocean alkalinity enhancement project if told it will be run by the technology that you are talking about, but also what exactly that looks like in practice in a given ecosystem or geographic context. Some projects have succeeded in finding the right fit. Planetary has received much more public support for field tests in its home of Halifax, Canada, than it did in Cornwall. So people in Halifax know Planetary and trust it. The company has trusted collaborator in Dalhousie, the local university, which is a good university, especially for ocean sciences and biogeochemical sciences, and its approach to public engagement has evolved. We move at the speed of trust, says Diana Phillip, a community engagement person. Oops, I read it the wrong way, but anyway, it doesn't matter. The specifics of the companies matter, not only of the technology that you're talking about, but also what exactly it looks like. Okay, so meanwhile, in the US, a startup called Vesta was able to run its first field trial on New York State's Long Island after the local community invited the company to come and pitch the experiment to them. Vesta aims to boost marine carbon removal by spreading highly alkaline sand made of olivine, a greenish rock, in the tidal zone, where the waves will erode it releasing its alkalinity, residents of the small community bordering what is arguably the world's first geoengineered beach are enthusiastic about their role in testing potential climate solutions. So it's the other way where people are saying, hey, we are a part of the solution. So how this got motivated is not always clear, but depends on how pro-environment they are and how well off they may be, what their concerns are. If they are not worried about employment, etc., then they may be much more open to experimenting and being a part of the solution, having agency in the solutions and so on. So despite the missteps in Alameda and Sweden, there's one place where solar engineering has brought public support. For the past 5 years, oceanographer Daniel Harrison of Southern Cross University has been leading a cloud brightening project off the northeast coast of Australia without local or international protest. On a ship over the Great Barrier Reef, the scientists have been spraying a fine plume of saltwater particles. So project aims to find out whether the salt particles will increase the albedo and reduce the sunlight coming into the Great Barrier Reef. It's a big operation. Below decks are 3 shipping containers worth of machinery to suck up seawater and generate salt. Carried out, there are crop fields over Queensland that they would worry about. The researchers have investigated and learned that the amount of salt they are producing was minuscule compared with the quantity that naturally bows in from the sea anyway, because there are tons of sea salt being lifted by ocean interactions with the winds, and that gets sprayed onto coastal regions. What they are adding is really tiny. So there are other ideas. Australia supports these kind of things. We are not just doing science for the sake of doing science. We're doing science to try and find solutions for the reef. So people have great affinity and identity associated with the Great Barrier Reef that they want to protect. So they are not protesting Harrison's efforts. We are the first ones to ever go and test anything outside, Harrison says. So though research points to the way scientists agree, there is no recipe book for climate tech engagement that can be used for each new project, but some structural changes could make the process a whole lot easier, social scientists say. We tend to say there is a project here, let's go and talk to people about what they want, Nawaz says, from UCSC, if you remember. The project level is a deeply flawed way to do engagement. We need to be thinking about what the impacts are at scale. So instead of communities being consulted over and over again for different climate engineering projects, Nawaz proposes that an independent authority could oversee a single consultation across the entire region to get a bird's eye view of the area's history, culture, ecosystems and resources, and figure out with the public input the types of projects that would best suit the area for the project. Geoengineering tests could be combined with the development of other climate-related infrastructure, such as the additional renewable energy sources that will be required by some technologies, so that you are not only reducing energy use for your geoengineering, the community is also getting something out of it. One thing is clear: effective technology and good intentions will never be enough to get climate engineering off the ground. There's no point having a technological solution if you don't have the social license to use it, Harrison says. If the community and the public don't support this, then it's never going to happen. And if you do it surreptitiously, then people are going to be very angry, even if you manage to deploy it and test it, because if something goes wrong, there will be a permanent distrust that will be hard to repair. Building trust is like building a bridge, takes a lot of time no matter how many resources you have, but it can be destroyed in a second by dangerous acts. You will be bombing that bridge of trust, and then you will recover. Maybe you will never recover, or may recover over very long times. Okay, so let me leave it here. So this is not purely geoengineering article. It's about all the issues associated with deploying geoengineering, assuming that they are going to be a critical part of the portfolio of solutions. Carbon capture is seen much more benignly than these other interventions like spraying stuff. But anyway, let's leave it here.